Hello and welcome to this new video where we will try to understand how cloud can handle chaos. More appropriately, we'll use our product Cyperf to identify certain choke points in cloud. So let's get right to the UI. So this is our Cyperf UI, and like any test, I will start with browse config where we have provided all these different examples for running tests for performance and cloud. In this case, since we are concentrating on cloud and specifically AWS, I'll use the configuration that has been created for AWS for high CPS. I have set this CPS to 300,000 HTTP connections, clear text. And it's a very simple test. I'm going through a C5N9X large agent, pretty highest powerful agent that is in VPC1, and we'll send this traffic directly to another agent that is in the same VPC. So VPC1 going to the same VPC1, one agent acting as client and the other acting as server. Very straightforward to find out the baseline, because baselining performance is key to understanding choke points. So let's start this simple test. So the test, I kept it running for a few minutes in the interest of time, and you can see we very easily reach that 300,000 HTTP connections mark, and we cannot go more. So we need to understand whether it's the Cyperf or the instance itself where exactly the choke point is. So let's go and find out through this agent metrics stats that we have added in our latest release. And you can see our CPU are utilized quite a bit, but not to the 90% mark. And you can click to see each CPU, and none of them are really stressed. So obviously, at least the instances have more room. Cyperf thinks it has more room. So if there is some choke point, that might be in the underlying infrastructure, or some ways the traffic has been limited by some other means. So that's what it tells us. This allows us to make decisions based on that. And what we would do now is to go ahead and add some complexities to the traffic. The easiest way to add a complexity to the traffic is by enabling encryption. Encryption is super CPU intensive task. So I'll enable TLS 1.2 with RSA, and because it's a CPS test, it would try a lot of connections and hence probably would put a lot of strain on CPU. I don't change anything else because that would allow us to give a proper apples to apples comparison. I'm still going from VPC1 to VPC1 with the same C5N9X large agents. So I ran the test again, started the test, and you can see now from 300,000 CPS that we achieved earlier, we dropped to somewhere around 26,000 connections per second. And I will go to same agent metric stat, and wow, there we can see that my server agent, this is the IP address of the server agent, is somewhere 95-96% used, and you can see each core is somewhere between 80 to 90%, 95% utilized. So you know that clearly we are reaching some sort of bottleneck in terms of the CPU resources that are available to us for this particular test. And if, let's say, a customer or user wants more than 26,000 TLS connections, they probably need to add more resources in the test tool itself. And there is nothing nothing in between that is stopping it. Now let's add another complexity to it to understand how choke points work. So I'll now remove the VPC1 server and add another agent that is running in a different VPC, although in the same US West 2. And what I'll do here is I'll add the public IP address of that server, because we need to reach the server through the internet gateway. And I will run exactly the same test with TLS encryption for my apples to apples comparison. So I will start this test by enabling the second server, which lies in VPC2. So you'll see the toggle happening to enable that server, and then I will start the test. So again, I kept the test running for some time, and you can see clearly there is some struggle going on here, real struggle. There is a sawtooth pattern, so we see some connection failures coming up. Latencies are through the roof, and we see the connections swaying. And in the agent metrics, again, it shows me clearly that my CPU, my memory is not stressed. It's barely even touched its median capacity, and it can go much higher than that. This also gives me an indication that the choke point now has shifted to somewhere in between, where it's either the internet gateway, NAT gateway, or the device and the test that might be sitting in between that's limiting the traffic. So with that, to summarize, in cloud, by running proper baseline and then adding complexities one after other, you would be able to identify choke points like we did. We started with the 300,000 connections, added encryption and went to 25,000, then added a different VPC and drastically got reduced to few thousand with connection failures. And every time we checked our agent CPU metrics, memory metrics to ensure the test tool, either whether the test tool is the blockage or the blockage is somewhere in between. Thanks a lot for listening.